Hello, everybody. Thanks to being here. I want to thank a lot Gabi, Maribel, and Mariano of having this idea of having us here. I am really delighted because it's the first time that I come to a conference of biologists, and it's amazing. I learned so much. Thank you very much. So I will change the scale in the geological point of view dramatically. Because, as geologists, maybe you as well as biologists, we are used to change in scale and in time. This is one of our main skills, the change in the perspective in different conditions in maybe hundreds of millions of years or to some dozens of years. We need to change it very quickly because we need to interpret the whole system. This is one of the things that geologists are trained for. So I will change absolutely the scale to the macro scale for the structures of limestones maybe because we are here. I wanted to present this very first review work about the structures of Cuatro Ciénegas and the influence in groundwater and surface water flow. And we began to work with this 2 years ago. We have some samples, but we don't yet have anything definitive. So I just wanted to present this review work. Please, some of the authors are here, so if I say something that is not correct, please make the comment. So I will talk about a brief introduction. ¿El de acá? ¿El grande? I will make a brief introduction about groundwater management in Mexico for those who don't know how it works, the administrative management. Then I will talk about some the main regional structures, how is the relation between surface and groundwater, and what is the many vulnerabilities of the aquifer system in this area, and some perspectives. So, groundwater management is not only an issue for Mexico, it's a global issue. We have a huge problem of water scarcity in this everywhere, but mainly in these latitudes, because these are the latitudes where the increase of temperature is going faster, and also the rain is fewer. No? So we have our problems of overexploitation of aquifers is becoming harder and harder globally. And even UNESCO has been aware of this for many decades, but for the first time in 2022, groundwater become a really issue and a really subject of research, because we talk normally about surface water because we can see it, but they did this conference making the invisible visible, because we never see groundwater. You go to if you are in your house, you open you take the water very easily, but you don't know where does this water come from. And the 60% of the water you are using at home is from groundwater. Right? So in Mexico, the CONAGUA, the Agency of Water Management, are organize the administration by dividing the whole country in regional hydrological regions, and each region has a so-called organismo de cuenca and a consejo de cuenca. They are supposed to take decisions. Here, one of each hydrological regions have their own organismo de cuenca that is supposed to be integrated by representatives of the federal government, but also from the state and municipal representatives, academics, and users. And every time they are making meetings and reports, and we can see little by little which are the regions the more stressed, with the most of water stress. So as you can see, we are here more in this regional hydrology. It is called Rio Bravo region, and is one of the most stressed regions in Mexico. Now we have, of course, Mexico City, we have the Lerma Chapala Basin as well, but because of climate conditions, one of those is one of the most stressed. That means that this is really not true. The official numbers of the overexploited aquifer in Mexico is that we have, from the 650 aquifers, only 105 are overexploited, and 50 with saline intrusion. But this is not true at all, because we have official numbers that is called disponibility of water for each aquifer. And the data of these studios is about 1994. So it's not updated at all. This is very, very old. And these numbers are unrealistic, incredible. Also worldwide, even that, of course, in Brazil, in Chile, in Costa Rica, Mexico, Paraguay, and United States in America, these are the main countries that extract the most of water. And globally, we also belong to the countries that extract the most. Only, we cannot compare because of the size with India, China, and USA, but even we have a really, really high rate of extraction of water globally. Now, how it works in reality. So, as everything in geology is not simple, we need to make the difference. It is very important for the geosystem that infiltration is not the same as recharge of an aquifer. If you have a rain here, and this rain infiltrates in this area, and it stays in the first layers of the sediments, or it runs to the surface streams, for example, it doesn't mean that it will go down and recharge the groundwater flow, which is deeper and deeper and deeper, because we are extracting too much water. Normally, we have groundwater flows more or less at 100 meters depth, and it's lowering by 1 meter to 5 meters in different parts of the country. So it's very important, because normally agriculture say, I will put so much water in my field, because in any case it will go to the aquifer. This is not true at all, because every drop will need to travel 100 of unsaturated sediments, if there are no faults or fractures for sure, needs to travel 100 of unsaturated sediments to impact in reality the groundwater level. So it's almost impossible. So it's important to note that the drainage, the water that moves near the surface, is different than the water that moves in groundwater, in depth, in the most of the cases. Like in central part of Mexico, when we have really stratigraphy very different, with high differences between the volcanic sediments and the sedimentary fillings. Well, here in Cuatro Ciénegas, it is one of the few cases where the aquifer is near of the surface, is in the most of the cases, and free, that we call free aquifer. And the exchange between the sediments, the surface flows in the near surface is very close to the water that is moving within the karstic limestones. So the communication is very easy, because the level in limestones is is not so deep. But even there are not yet really hydrogeological studies that make the connection between the first karstic aquifer and some other aquifers in depth, also karstic in the same limestones, And there are no studies about this connection, because if I well understood, we are deep aquifers are more than 50 meters. We can record this in the wells used for agriculture. But we also have a lot of movement in a shallow aquifer, a karstic shallow aquifer. So even that these are different layers, geologically and physically different, they are all connected because of fractures, stratigraphic joints, and dissolution, karstic dissolution. That means that if you have a granular aquifer, normally the water are in the pores between the grains of sands that maybe can be obstructed by cementation. But this is, in a way, this drawing is more or less the representation of this kind of material. But here we have this karstic aquifer where water moves very, very fast, and it can be dried in a very, very short time. So the vulnerability of karstic aquifers is much higher than granular aquifers. Now, coming to Cuatro Ciénegas. Mariano wrote a paper recently about the deformation in this area. We all have been talking about the formation of limestone in this area, and I am really happy to show that the most of you are talking about the formation and faults and trust and faulting systems. So I just wanted to have this drawing because to make you see how this deformation happened. It's not because somebody is pushing in this direction or in this direction. It's this relative arrangement between tectonic plates. Because we have the Laramide orogeny, and we have, because of the subduction that we have in the Pacific, we have this huge push of Cretacic sediments in this direction, and we have different paleotopography here, basins, islands, that are pushed by the same huge compressive force, but the forms differently because it's not the same as you have if you have a huge map of limestones, or if you have an island, or you have a platform in the middle. This is why the deformation is not homogeneous, and we have different kinds of faults, and we have different kinds of systems of fractures. As we of course we can see in all the amazing structures we can see in this little area around Cuatro Ciénegas. So here we have a structural map made by Gabriel Chavez from the University of Linares. Also, Dr. Jorge Aranda has worked in this region. By the way, I want to invite you for the field trip that we will have on Sunday, and we have a super guides with a lot of experience that will show all these structures on Sunday. So you are invited to come with us. But the interesting thing for water in general is the topography at the end. So we have a surfacial drainage over sediments and over limestones that goes in a certain direction. Normally is to the down, the basin with the less elevation. Here we have 770 meters of elevation. But we have also all the paths that has been formed because of this folding, these fractures, the stratigraphic joints generate also different paths for groundwater, for water when it runs in the surface. We have this kind of structure, recumbent faults in a specific direction. So here we have La Sierra de Alamito, Sierra La Fragua, Becerra, San Marcos, Poza Azul. Each of one of those are directly related to the structure because all of these discontinuities are taking the water and generate pathways for easy pathways for the water to go underground, and sometimes because of topography go in the surface again because of hydraulic gravity. This is a map of a thesis, Santillán in 2007. I put it because it's very nice to see how we have different lithologies in the surface as well. We have fine-grained sediments in the geological point of view. We have the dunes. We have alluvial deposits, and we have all these granular materials that are filling the basin in recently. Now, what in particular, there is a guy, Bolivar, maybe the most of you know him. He made his PhD thesis in Texas, studying the aquifer of Cuatro Ciénegas. And it's interesting because at the same, he made his PhD thesis after the study of the INTA, who decided that there are no correct hydraulic connection between the different basins. And he's saying absolutely different, as many other authors that work between 2004 and 2013. There are so many works studying isotopic data, geochemical data of water that prove there are very, very dynamic hydraulic connection between these basins and between the surface sediments, middle sediments with karstic limestones, and deep sediments. So I will not go in details, I only want to show you a very quick view. But there is also a study that Magner and Newton made in 2017 because they wanted to know if the Cuatro Ciénegas state of conservation can be similar with the a dune system that they have that is called white sands in the side of the states, and they wanted to know if the evolution can be the same for both dune systems. And they came here, made a lot of studies, and also identified these regional groundwater flows, the deeper and intermediate groundwater flow, and the surface groundwater flow or local flow in the near surface. But it's interesting because he said so. The conclusion of this work was that because of the drawing of the first level of water, the most sensitive, because if it flows for 5 or 3 meters, it's really a catastrophe. They said because the dunes are not more sustained, but this little quantity of water, they can erode very easily, and the whole system can disappear just because they do not have this capillarity water that make the whole system to be together. I need to hurry. Okay, so I will go quicker. You can consult this work of Bolivar. This is really very good. He wrote a paper in 2013 with an update of geochemical analysis. He identified the groundwater and surface water flows. I just wanted to show you this drawing because we can see a fault, but a fault is very, very different from another one, and the system of fractures are very different between each thing. And this is a specialist this is a problem of structural geology, but also for hydrogeology as well. because each kind of fracture system, each different arrangements make different paths for groundwater to go. This is an example that was reported in La Becerra, where this fault crossed the fossas, and we have this exchange with this karstic dissolution and structural discontinuities coexistent that prove that they are all connected. So we have very well documented the springs. Where are the main springs? The different levels of each one for different seasons, the surface water flow and the relation with the groundwater flow, the structures that are involved for each one of these patterns. Also, Dr. Aranda has worked with these structures as well. And more than that, 1 minute please. We also have hydrothermal groundwater flow, and we don't know really what is the hydraulic influence. We only notice that the chemical composition is different in sometimes with different major ions, slightly variation of temperature because they mix with surface water is not so high the contrast, but it exists. So, because of the volcanic activity that we see, we have the evidence that we have some magmatic activity in depth. I don't know which depth, but we have the hydrothermal fluids coming in the surface that are changing the system. So this is also to integrate in the complex. This is a pattern diagram showing the different families of water. Quickly. The different groups of distribution. These guys made a very nice model of groundwater flow with integrating the structures, the different levels of groundwater. Here there's the local flow, intermediate flow, and regional flow. And I wanted just to finish this, that all of this connection, hydraulic connection, all of this sensitivity to very little water levels makes a high vulnerable aquifer system, not only because of the relation with the ecosystem, but of the potential pollution to the aquifer itself with municipal residuos municipales, with all the fluids, the nitrates for sure, agriculture, all the industrial activities have an impact directly the quality not only of the shallow aquifer, but also the intermediate and deep aquifer. So an update of this model is urgent to be done to evaluate these connections and to quantify the drawdown of the aquifer in the next 10 years. Thank you.
Thank you. Time for just one fast question. Mario, if you want.
Thank you. We noticed yesterday that in Ocampo, the next valley, which is very connected to this one, there is a new sanitary landfill.
Oh, really?
A big one. Can you comment on the implications of such?
I'm very glad to hear that.
On the water here?
Yes, for sure. Landfill needs to be created in following the 83 norm. There is a system to build these landfills with a geomembrane that protects, with some fine deposits to protect the aquifer. And I was very worried about because we didn't see a landfill elsewhere. It's pretty new.
I don't know how new it is, but it seems to be a new,
I'm very
and it's just
here
right in the middle of the valley.
Because of the potential of pollution, if you don't use it, is huge. Yeah.
There's a little time since they are uploading the next presentation, so if somebody wants to ask something very fast. Elizabeth.